Hi, everyone. My name is Shailen Tuli. I am a developer programs engineer working on Android at Google. And I'm here to talk to you about building great apps for Android O. Android O is kind of a big topic. There are lots of cool things in O. And there's a talk later in the afternoon that's going to cover many of them. My talk is going to focus on a couple of topics. Basically, what you can and cannot do with regard to background work in your O apps, and what you can and cannot do with regard to location gathering when your app is in the background. This is going to be a fairly technical talk. I'm going to focus on just those two issues. And I have a lot of material, so I'm going to go a little fast, so you've been warned. OK, so why focus on background so much? Why focus on background limits that are coming in O and all the location limits? Because first, I believe these are some of the biggest changes in the platform. And these are changes that have really, really great consequences for you app developers, because I believe these changes make Android an even better platform for writing apps. So that's what I'm going to be focusing on. I'll talk, of course, about what the changes are, what strategies you can use to deal with them. I'll talk also a little bit about sort of historically how we have come to this point where we have to limit what kind of background work goes on in generally and specifically with regard to location. So sort of a little historical overview of things. OK, so pretty much everything I'm going to cover in this talk relates either to system health, basically good RAM management, or to battery, to how to get more battery performant stuff happening in your apps. What I'll do is I'll start with a little overview, just talk about a few things that sort of just give you a sense of what's really happening in O. And then we'll do a deep dive into each of these topics afterwards. So the first thing with regards to system health is there is a limitation now in O that there will be no started services in the background. This is kind of a big deal, but it really only applies to started services in the background. When you're in the foreground, there is no limitation to started services. You can keep doing what you're doing now. The other system health issue is that there will be fairly substantial limits on implicit broadcasts. So you can still have explicit broadcasts. You can dynamically register for broadcasts. But broadcasts that go into your manifest, there's going to be quite a lot of limits placed on those. Again, we'll explore these. So the question is, when? When do all these things happen? When do you have to start worrying about these things? And the answer is when you increment your target SDK version to target O. Now, that may seem like distant to some people, maybe not so distant to others, but I would urge everyone to start thinking about this and thinking about it now, because even today, users of your apps can go into their settings of their phones, figure out how much work you're doing in the background, decide if that work is too much, and essentially curtail that work. So, like it or not, the limits on background work that you can do, those are here already. So it's something that you as app developers kind of have to deal with. You'll deal with them much more substantially when you upgrade to O, but you have to deal with them now as well. So that's all system health. So let's talk about battery now, and that's pretty much the focus of the changes that are coming in O or have come in O. So basically what's happening is that for battery reasons, what kind of location gathering you can do in the background is going to be substantially throttled. So if you have gotten used to the idea of having very frequent updates, for instance, in the foreground and in the background, the foreground stuff is going to remain the same. The background stuff will be quite different. And so the question is, when does this kick in? When do these limits kick in? And the answer here is they kick in now. For any app that is running on an O device, regardless of SDK version, these background limits with regard to location are here. So this means that if you have an app that does something with location and your target SDK is N or M or L, that app may actually behave quite differently without you having without you having to change a line of code, that app, when it's run on an O device, is going to start behaving differently, could behave differently. So this is a fairly significant change as well, and it's something that if you have a location component to your apps, you're going to have to deal with. So these are big changes, like no started services, limits on what you can do with broadcasts, limits to what you can do with background. So the question is, why are we doing this? How did we get here? What's really going on? So the first thing is, we're not doing this because we like being difficult or we just like making people's lives difficult. We're doing this because this is essentially better for the platform. It's better for the users. The users want you to build apps that are really, really performant, that do really great things with RAM management, that do really great things with battery. The changes that we've introduced in O have been a long time in the coming. So we'll get to all the details in a minute or two, but I'm going to take a little while and just talk about how we got here, starting in Marshmallow. So go back to Marshmallow, and you remember that's when we introduced DOS. So what's DOS? Just to recap, that when your device is stationary, when it's not charging, when the screen is off, essentially when it's not being used, we said, you can't just go crazy and do all sorts of things in the background. You've got to channel all your background work into very narrowly defined, well-defined maintenance windows. Because frankly, when a device is just sort of sitting there, it should not be doing really crazy things. It should be a very well-behaved, quiet machine. So that's where DOS came in. Android M also gave us App Standby, and the idea there was that if you have background network activity, how that activity was done was actually dependent on how much or how little the user was interacting with your app. Again, the idea is if there's background work being done, let's just do this very carefully. And in Android N, we gave you DOS Lite, which is basically like DOS, but the difference is that the device is not stationary. So think of, I have my phone right here. It's not on. Obviously, it's not charging, but it's moving because I'm moving. And again, the idea was, even then, you do background work pretty carefully. So all of this started off a couple of releases ago, and what you're seeing in O is pretty much a very natural progression of what we introduced in M and in N. So the other stuff that's very significant is, starting in N, we started paying attention to some broadcasts that we felt were excessively noisy. They were causing system health problems, thrashing, very visible jank for users. And we decided to curtail what you could do with those broadcasts. So in Android N, we said, for instance, the connection action broadcast, you could not anymore listen for this in the registered, and you could no longer register for this in your manifests. And the reason was that it was an extremely noisy broadcast. We didn't want to be waking up apps to inform about connectivity changes. It was too expensive. Similarly, there were two other broadcasts that were targeted in N, and that's action new picture, action new video. These are fired when a user takes a picture or creates a little video. And so action new picture is actually a great example to consider when you think about what the system health implications are of allowing a broadcast like that to happen. So imagine a user takes out their phone, takes a photograph. At that point, there are, let's say, 20 apps on the user's device which have registered for this broadcast. The system says, all right, let's go. Let's wake you up. Off we go. 1, 2, 3, 4, 5. And each of those apps now wants to do some really great, impressive things, because who doesn't want to impress the user, right? And so they start services, they start expensive stuff, and before you know, the system is saying, hey, apps 6, 7, 8, I can't really launch you before I kill off 1, 2, and 3. And so on and so forth. And so the system is, in this point, in turbulence. It's launching stuff, it's creating stuff, it's killing stuff, doing whatever it can. Heaven forbid the user takes a second or a third picture, it goes even more crazy. So in Android N, we said, this is no way for an operating system to be behaving. You cannot register for these things in the manifest. We're not going to be waking up your apps. We're not going to go crazy every time somebody takes a picture or makes a video. So that's the background of that. Now, the location stuff that we're going to talk about is largely driven by battery concerns. and battery has been a huge issue for us year after year after year. In our surveys, users tell us, that 1 in 3 users say that battery is the #1 concern for them about Android. And what happens is users, rightly or wrongly, associate location with battery drain. And because they do that, they go and disable location altogether, which makes all the nice apps that you guys have written either not work at all, or they work in a degraded manner. This is not good for the app developer, it's not good for the user, it's not good for Android as a platform. So this time in O, Google has taken a very serious approach to battery management and targeted background usage of location as a primary culprit, which needs to be sort of carefully managed for battery to work well. All right, so that's the historical stuff. One more little segue before we dive into the O limits, which is that all through this time we're going to be talking about started services, implicit broadcasts, background location, and it's a good thing to take maybe a minute and say, what exactly is foreground, what exactly is background? It's sort of obvious at one level, and maybe not so obvious at another. So the obvious stuff, when you have a visible app component, when the user can see your app, when your activity is started or resumed, you're in the foreground. When you have a widget, you're in the foreground. Fairly obvious. When you have a foreground service, you are considered in the foreground. Kind of obvious. It's a foreground service. Don't let the service part fool you. Stay with the word foreground. You are in the foreground with a foreground service. When you have a bound service, and there is a client in the foreground binding to that service, you are then also in the foreground. When you have a content provider, and there is something that is in the foreground accessing that content provider, you are then also in the foreground. And then there's a slew of sort of very specialized cases, which if you read about these, you will understand, yeah, these kind of have to be foreground. An accessibility service, for instance, has to perform all sorts of actions on behalf of the user. It has to be considered foreground. Notification listener service, abstract account authenticator, wallpaper service. You can find documentation on developer.android.com explaining all of this pretty carefully. The good news is, in all of these cases that I mentioned, nothing that relates to background limits in Android O applies. None of that. You can keep, if you're in the foreground, you can pretty much do whatever you could do in any release up till now. Nothing really changes for you. But when are you now not in the foreground? When are you in the background? So you're no visible app component, so your activity is stopped. There's no widget. You are in a started service that is not a foreground service, so that would put you in the background. You are in a job service. We'll be talking a lot about job scheduler and jobs later on, but when you're in that part of the code, you are, again, going to be in the background. And when you're dealing with broadcasts inside your broadcast receiver, you also, in this time, are in the background. And all of these cases, the background limits that have been introduced in O, they will apply. So it's kind of a big deal. Trivial apps can do without dealing with broadcasts and services, etc. Most people don't write trivial apps, they write mature apps. Those apps will be affected by these changes. So I'm going to dive into services and what's changing with services in Android O. Lots of fun stuff. As I said, this is a pretty technical talk, so we'll go deep into this. From now on, applications can no longer freely execute background services. So the idea is we want you to stop thinking about services and start thinking about jobs. Move to Job Scheduler or Firebase Job Dispatcher for the kind of work that you would currently give to services. Apps that are doing ongoing work with regard to broadcasts should also start thinking about jobs, because starting a service, for instance, to do something in response to a broadcast will no longer be possible. The idea behind these changes is fundamentally that if expensive work or potentially expensive work is being done on behalf of the user should be aware of that. It should be visible to the user. If you are doing things that cost the user data, battery, RAM, whatever, the user should sort of say, hey, I know you're doing this. I approve. This is making my app experience really quite good. Keep doing it. We don't want expensive work sort of happening quietly in a clandestine manner without the user's approval. So that's the guiding principle behind a lot of these changes. So now what happens if you do call start service and you're not in the foreground? You get an illegal state exception. If a pending intent is involved, then you won't get this exception, but it still won't work. You'll get a log warning. Basically, there isn't a way, when you're in the background, to start a service anymore. So this is kind of a big deal. I don't know if you think it's a big deal, but when I first found out about this, I was like, whoa, that's a big deal. But there are actually some very practical ways in which this is softened up. So one of them is that there is a grace period. So services continue to run on for a while once you lose your foreground status. So take an example of you have an app. The app does the user is using the app. It launches a service. The service is doing fine. And then the user swipes away your app. It's gone now. It's no longer in the foreground. The service won't be killed off immediately. There will be a few minutes of grace period where the service will continue to run, at which point the system will step in and say, OK, enough of that, and it will kill off that service, but it won't be immediate. And effectively, what will happen in a few minutes is the service's onDestroy method will be called, and it will be as if the service had called stop self. The system will just do that for you. But it's nice that it's not abrupt. There is a grace period. The second is, I think, the realization that sometimes when you are in the background, your app is going to want to respond to certain events. They may be very user-visible events. They may be other kind of events. And for that, there is a process to temporarily whitelist apps, to temporarily treat apps as if they were in the foreground for doing very specific things. This is probably best explained with some examples. So let's say you have a high-priority cloud message coming down to your device that pierces those restrictions, and your app now wants to do something with it. So we give you a period of a few seconds, less than a minute, whereby you can be considered foreground and you can launch services. Similarly, if you have an SMS or an MMS delivery, you may want to respond to that. So again, there is a short window where you're given temporary foreground status, and you can respond to that. And in Android O, notifications are kind of a big deal. When you are responding to a notification action of any kind, and there's a pending intent involved, at that point, you are treated as if you are in the foreground. So this is sort of a very pragmatic approach that the framework team has taken. They've said, by and large, we don't want you doing expensive work in the background, but we do understand that there are some cases where you'll need to do it, and here's how you do them. So this whitelisting process should, in fact, help most developers target what they need to do pretty effectively. That's our hope. Foreground services are not affected by any of this. So you can have a foreground service, have a persistent notification, the user sees that, and life is good. The only problem is that foreground services have typically been done in two steps. You start a service in the background, and then you promote it to foreground. The first part is not going to work anymore. You can't start services in the background. So there's a new API for starting foreground services. Essentially, it does that two-step thing, and it just does it for you. We'll talk more about foreground services and the appropriateness of foreground services in a bit. So a question I was asked when I did this presentation in India by a developer, he said, do you expose any kind of API where I can tell if it's safe to start service or not? No, we do not. It's for the app developer to figure out when it is safe and when it is not safe to start a service. Essentially, you have to sort of do your homework and figure out when you're in the foreground, when you're not in the foreground, and go with that. So that's the gist of the services part. A couple other points to tidy up. Bound services are unchanged. Because we're thinking much more about foreground and background, there are some sort of semantics of this that are interesting. So for instance, if I am bounding If I'm in the foreground and I'm binding to one of my own services, that's no big deal. If I'm in the foreground and I'm binding to somebody else's service and they're in the background, then they too will be considered foreground, because a foreground client elevates their status to foreground as well. So these are sort of things that as you start thinking in sort of O semantics, in O terms much more, will be very obvious. It's not something that I thought a lot about when I was writing code. So this is going to be a little bit of an adjustment as we go into O. All right, here we go. Question that's asked to me, what about intent services? You've talked about started services. What about intent services? Intent services are just services. They are started services. Everything I've said about started services applies to them. And in fact, this is kind of a big deal. So the support library now has support for the job intent service class. And that's supposed to be a replacement. It could be considered a replacement for intent service. We'll talk more about this in a bit. Fundamentally, we would like to start thinking that jobs are the way you want to go about this. Services, expensive broadcasts have served us well, somewhat well, up till O, but from now on, job scheduler, Firebase job dispatcher, and jobs are your real Swiss Army knife as you go forward building your apps. So that's services. A lot of stuff to take in, a lot of changes. So I'm going to throw more stuff at you now about background limits and broadcasts. So the limitation is on implicit broadcasts. And the gist of it is that limits to implicit broadcasts delivered to manifest-defined receivers are not going to be honored for the most part. So at this point, the question comes, what is an explicit broadcast? What is an implicit broadcast? If you go to Stack Overflow, you'll see all sorts of confusing answers about that. And the answer here simply is, if a broadcast is explicitly targeted at something, at someone, at some package, some app, then it's an explicit broadcast, and you can put it in your manifest. If it is not, if it's a general broadcast that is sort of sent out into the wild, it's an implicit broadcast, and you should not put it in your manifest. So take, for example, action package replaced. Action package replaced, if you register for this in Prefor O, in N and lower, you will have this broadcast go off every time any package is replaced on your device. That's pretty noisy, right? Contrast that with action my package replaced. In this case, the broadcast is sent only to me because my package has been replaced. So this is kind of a big distinction. It's not always incredibly intuitive, but I think this is something that developers will have to think about. Explicit broadcasts can still be put in the manifest, no problem. Now, there are some implicit broadcasts that the framework team has understood need to be allowed. And they are, and if you follow these, there's a pretty good reason why each one of these is permitted to still be put in O world in your manifest. So action boot completed. Okay, this fires once. It's required by apps to set up jobs, alarms, et cetera, et cetera. It's not hugely disruptive. It's okay. Action locale changed. Well, your locale presumably doesn't change a whole lot. And when it does, it's not totally unreasonable that apps will want to respond to that. Action headset plug. Now, this is, the user plugs in their headset. So at that point, there's a user action involved. It's not entirely unreasonable that some app is going to want to respond to that. Again, this is not hugely disruptive. When you have received an SMS, you'll want to respond. This is a very partial list. The whole documentation is there, or android.developer.com, and it will explain to you why all these broadcasts, while they are implicit, are still actually completely okay. The dynamic registration for broadcasts is completely okay. Nothing of this has changed. So you can always use context.register receiver, and as long as that context is valid, you will get whatever broadcast you registered here. So that's completely okay. It's not changed. The idea is if your app is being used, there's an active context, and you register for a broadcast, it's not hugely disruptive for the system to give you that broadcast. But if your app is asleep, that's a different thing. So that's the way to think about these limitations that are being introduced in O. So at this point, you're thinking, well, this is fantastic for users, right? Your battery is preserved, your system health is so much better, no long-running services, all the noise that was generated by these broadcasts, that's pretty much quieted down. What about me, the developer? I had all these great ideas, all these great plans. What am I supposed to do? So let's talk a little bit about that. What you can do is a bunch of strategies. So first, instead of having long-running services, if there is some external stimulus that changes something in your app or that wants to change something in your app, use cloud messaging. It's fantastic. You can use a cloud messaging. If you use high priority, it'll pierce through those, it'll give you temporary foreground status, and you're good to go. If you use normal priority, that's still very good because now the operating system can very judiciously, carefully, efficiently schedule the work that you want to do. Normal priority should be your default. You don't want to abuse this, and you want to preserve the system health that comes from that. Another thing is you can use job intent service. I had mentioned that a few slides ago. Job intent service is part of the support library. It's very new. It should be considered a replacement for intent service. And basically what it will do, it's aware of background limits, and it'll just sort of do the right thing. In pre-O apps, it will run context.start service. And in O and beyond O apps, it will run jobscheduler.enqueue for work. So this is a pretty good way to sort of have all that abstracted away and you don't have to think about it. Wakeful broadcast receiver is now deprecated. The whole point of wakeful broadcast receiver was that you're handling a broadcast and you kick off a service or something like that. You can't do that anymore, so there's really no reason to have this sticking around. And finally, and this is kind of an important conceptual point, you want the operating system to be your friend. Right? So go back to that example I gave of somebody taking a picture which spins off the starting off of 10, 15, 20 apps, all of which are now starting services. At that point, the operating system can do one of two things. It can either run your app or it can kill your app. It cannot do anything else. It'll try to run everything, but when it stops, when it loses the ability to run everything, it'll start killing things. You don't want the operating system to be turned into a killer. You want to schedule your work to be scheduled intelligently by the operating system. So for that reason, it's much better to use jobs. When you use jobs, the operating system can say, all right, 1, 2, 3, I run you now. 4, 5, I run you. I run 1 again. It can schedule that intelligently. So you want to go for that. We encourage you to use Job Scheduler as much as you can. And the big topic, you can use foreground services for doing all sorts of great work, and there are no limits. So a very big temptation would be to say, oh my God, so much is changing in O, I'm going to just slap on a foreground service, and I don't have to think about this. The problem with that is the foreground service has a certain meaning, right? When I'm listening to music, when I'm in a fitness app, when I'm using maps and navigation, it makes sense that there is a notification at the top and that it's doing work for me even when I'm not actively engaging with the app. If that is the case in your apps, great, use a foreground service. It's a fantastic idea. But if it isn't, the users are going to start wondering why the hell there is this persistent notification at the top telling them that you're doing expensive work that they don't understand. They'll probably either stop that work or, worse still, uninstall your app. You don't want that to happen. Use foreground services if it makes sense. If it doesn't make sense, think of all the other strategies that we've outlined and go with those. And finally, since O is pretty much putting you in a position where you have to think about background and what you're doing in the background, I think it's a good time to ask, do you really need to do all this background work? I think there has been a sense for many, many, many years now in Android that it's cool to just spin up something and have it run forever in the background, and the system will somehow handle it. Well, now the system is telling you, no, we don't want to handle it. We don't want this to happen. So if we are really at the point where we are questioning all this, it's a good time to ask, hey, I started doing all this background work 3 years, 4 years ago in my app. Do I really still need to do this? The answer sometimes you will find will be, no, I don't really need to do this, in which case you shouldn't. All right, fast segue to location. So first of all, location is kind of a huge topic. It's used in a ton of apps. In fact, when I started looking at logs to see who was using location, I was surprised. Like, oh, I didn't think all these apps were using location, but they are. And in Android O, the limitations on location are actually very significant. So let's talk about those. So again, as I mentioned, people treat location as they associate that with battery drain. They turn off location, and your apps don't work properly. So we believe this doesn't help anyone. We believe that location should be used wisely. It should be used efficiently. It should not be conflated as automatically with battery drain. We want people to love their location apps, right? So this is where kind of big changes have happened in O. And you will see, while this may seem a little dramatic at first, you can see how much better an experience this will be going forward for app developers. So the location limits are that background apps will receive location in a very throttled way. So when you're in the foreground, you can pretty much request location, I don't know, as often as you want. Let's say you want updates, you can have location updates, 30 seconds, whatever. Once you go in the background, we will give you location updates a few times an hour. That's it. So this is kind of a big deal. And this will happen regardless of the target SDK version. So on your N apps, your M apps, your L apps, and whatever, this will start happening now, the moment O devices start appearing on the market. You can use batching, and what that does is it collects location ever so many times and then delivers all those location data to you in a single, in a batched way. And that's a way that you can get more data points. You trade latency for more data. But your data will still be delivered only a few times an hour. This changes in O to Wi-Fi scanning. So we could have an entire talk about what makes location expensive, what doesn't make it expensive. But GPS is very expensive, super accurate, but very expensive. Wi-Fi isn't actually that cheap. So now the deal is that no location computation will be performed when the device stays connected to the same static access point. There's no need for it. Your location isn't changing. We're going to sort of be very judicious in making Wi-Fi scans because they're expensive. And this is good for a lot of people. For me, I spend, I don't know, at a time, 8, 10, 12, 15 hours at home. I'm connected to the same Wi-Fi. Why the hell does location services have to compute my location over and over? It's not changing. Similarly, when I'm at work, and I spend 8, 10, hopefully not 15 hours at work, again, I'm connected to the same Wi-Fi. Nothing's changing. Why does location service have to expend energies trying to compute my location? Most people spend a lot of time at home or at work. So there's a lot of changes to Wi-Fi scanning that actually make O much better. There's also changes in O to how geofencing works. So it was quite normal up till O to scan for geofencing every few seconds. And we have now made that not every few seconds, but around a 2-minute latency. This is sort of vague. But what we noticed that even going from, let's say, tens of seconds to 2 minutes for geofencing latency gave us dramatic battery performance. In some devices, it was 10x. It's a little bit device dependent, so it's not always going to be 10x. But we found it to be really quite dramatic. So that's another change that's come. So this is all, up till now, everything I've said about location is about what happens when you run your N app, your M app, your L app on an O device. What happens when you actually start targeting O? What happens to location? So the first thing is, we've always told you when you request locations, use a pending intent .get service. That's one of the arguments that you pass to the request, to your location request. You can't do that anymore because it's O, there's no get service, background services can't be started, so you're going to have a different strategy, and that strategy is you use pending intent or get broadcast, and then you go and register an explicit broadcast in your manifest, and that'll work. So the targeting of O is not hugely hard. I think it should be fairly painless to do it. Getting adjusted to the idea that you are running on O when you hadn't planned to is going to be an adjustment, and I would urge all of you to start thinking about this fast. So, what are good location strategies? Like, what can you do as developers now? Because, frankly, with the location stuff, these changes are here now. Sooner or later, O devices are going to start showing up, and people are going to start running your apps on those O devices, and then they will notice that location works differently. So, a very good strategy, instead of having long-running services or expensive and very fast location updates in the background, is to start using geofencing much more. We have generally found that people use geofencing less than we would like them to. Geofencing is very, very, very supremely optimized for performance. So for instance, if I have a geofence around the Krakow airport, and I have a geofence around the airport that I will be flying to in a couple of days in San Francisco, location services knows that there is no chance, that there's no reason for it to expend any cycles trying to track the geofence that's in San Francisco. I'm not there. But it also knows I'm actually not that far from the Krakow airport, so it will very carefully and judiciously monitor that geofence. So a lot of the use cases for location updates involve updates around an area. When am I near home? When am I near a restaurant? When am I leaving a place? Et cetera, et cetera. And geofencing can be a huge, huge asset. So please use it as much as you can. Use batching. So I promised that I'd talk more about batching, so I'll do that now. Essentially what you're doing is, when you're in the background, you're only going to get updates a few times an hour. But you can get more data points as long as you're prepared to give up. The trade-off is with latency. Okay? So here, look at this code now. So you create a location request. You set its interval to be 10 minutes. So you say, give me location updates every 10 minutes. And then you say, but deliver them no later than 30 minutes. So in a normal situation, what will happen is you will get 3 location data points every 30 minutes in this kind of a case. If you didn't set the max wait time, you would not get batching, and therefore you would miss out on data points. Another very, very important location strategy in the age of O is to get your location passively. So what are we talking about here? Basically, location is computed on a device basis, not just on an app basis. So when your app is in the background and therefore getting fairly infrequent location updates, another device, another app may be in the foreground. It may be a mapping app. It may be some other app that gets location updates quite a lot. Location services, free of charge, will make that stuff available to you, the data points available to you and to any other app that's in the background and wants that data. So this kind of opportunistic location gathering, I think, is extremely good. We believe it's underutilized, and we would like developers to use it much more. So here's an example how you can do that. Again, you create a location request. You set the interval to 10 minutes. You set the max wait time for batching to 30 minutes. But then you set the fastest interval to, let's say, 2 minutes. Meaning, if I'm in the background and anybody else is consuming location data, every couple of minutes, let me know about that data. And given the sheer number of apps that use location, there's a pretty good chance that when the user is using their phone for something else, they will be gathering location data, and then you can have it for free. So that's a very important strategy. I would urge all of you to use it. While you're doing all this, because of these changes in O, we're putting developers in a position where they kind of have to rethink their location strategies from scratch, right? If you're going to do that, you might as well rethink them from pre-O apps also. If you're running an N app or an M app or an L app, that too could use from the same principles that we are putting forward in O and become more battery efficient. So why wait? You can start making things better now. So fundamentally, location is expensive in one of three ways, related to frequency, latency, or accuracy. So O is saying to us, on the frequency axis, it's saying that when you're in the background, you need to not be so frequent. You can implement that now for your N apps, for your M apps. Again, latency. Sometimes it's okay. Sometimes you want the real-time experience, but sometimes it's actually okay to wait a few seconds before you get the location data that has been computed for you. So use batching, like we just talked about. You can do that now. If you're using a geofence, you can use a responsiveness time, and the more you give it, the better your battery performance will be. You can do all these things now for your apps. And when you're at it, I mean, O isn't really dealing with accuracy that much. If you're rethinking everything in regards to location, you might as well also say, do I really need high accuracy all the time? Maybe I can use a balanced power accuracy, maybe no power. There are a lot of options. You can read our documentation on this. Do I need the best, greatest, most expensive location updates all the time? Probably not. And finally, foreground services. You can go right ahead and just completely bypass all these location limits in O by running a foreground service, but you just have to make sure the user will really approve of that service. Otherwise, they will get annoyed with your app, and they will probably uninstall it. Don't want that. That's basically it. A lot of stuff. I'm around. If you have apps that you think are going to be now struggling with some of these O limits, please come and talk to me. I'd love to hear your story. And happy coding. Thank you.